For assignment number 10, we're going to finish up our unit and do some applications of trigonometry. And the majority of the applications is going to be finding the height of something that you can't measure directly, say the height from here to here. You can directly measure that, say, with a tape measure, but you can actually use sine, cosine, and tangent in order to measure that height by measuring the angle. And you're going to hear two names today. One's called the angle of elevation or the angle of depression. And then a lot of times you can measure the ground where you are, the distance, say, from the person to the ground using a tape measure. So as long as you have those two measurements, a side of a right triangle and the angle, you can use sine, cosine, or tangent in order to find the height. So there's two different angles created in this picture. One is called the angle of elevation. So elevation means going up. So if you look at this angle right here, the 38-degree angle, it's an angle between a horizontal line. So this dashed line is the horizontal line. And a line of sight, meaning this person is looking up. And if you notice that 38 degrees is above the horizontal line. So angle of elevation means you're looking up at something. So in this case, he's looking up at the hot air balloon. Angle of depression would be the opposite. You're looking down at something. So it's an angle between a horizontal line. So again, here's that horizontal line, that dashed line. And a line of sight where the person in the hot air balloon is looking down at the person. And so the angle is below the horizontal line. So this 38 degrees, that's below the horizontal line. And the two horizontal lines are parallel to each other. And if you look at the angle measurements of the angle of elevation and depression, they're both 38 degrees, so they're equal in measurement. And the reason they're equal is if you have two parallel lines, the horizontal lines are parallel, and you have a transversal, this would create alternate interior angles. If you remember, these two angles are inside the parallel lines alternating. One's on one side of the transversal and the other's on the opposite side. So those would be alternate interior angles, and those are always equal. So from this picture, we're actually going to draw an altitude. So an altitude, let me just fill this in, an altitude. We're going to be drawing from the top here where the hot air balloon is, and an altitude drops straight down and makes a 90-degree angle. So it's perpendicular to the side that it intersects here. And when we create that altitude, we're actually going to have a right triangle that's formed. And so that right triangle helps us use our sine, cosine, and tangent ratios in order to find a missing part of that picture. So in this first example, we're just going to identify the four angles here in this picture as either an angle of elevation or an angle of depression. So the way that we do that is we just look at the horizontal line and see if the angle is above, that would be elevation, or below would be depression. So if you look at this angle here, angle 1, notice that it's below the horizontal line, so that would be an angle of depression. Taking a look at number 2, this angle here, that is above the horizontal line, so that would be an angle of elevation. If I look at the third one here, that angle is below the dashed line, so that would be an angle of depression. And then lastly, if you look at angle 4, it's above the dashed line, so that would be an angle of elevation. So for our very first example, we're going to be finding the height of a palm tree that we can't directly measure, but we're going to be using indirect measurement, meaning one of our three trig ratios, sine, cosine, or tangent, in order to find that height. So I was goofing off here. It's summer break. We're going to see if, I don't know if we're still quarantined or not, but maybe you're at the beach. Suddenly you spot a palm tree, and of course you have to know its height, right? Can't go on without knowing. So obviously I'm being a little bit sarcastic here. So you measure the shadow, which is 30 feet long. So I'm going to redraw this picture. So it creates a right triangle. Okay, and then you measure the shadow, which is 30 feet. And then it says that the angle of elevation is 25.7 degrees. So elevation means it is above the horizontal line. So in this case, your horizontal line is your ground. So the angle of elevation right here would be 25.7 degrees. So that's enough information to find the height of the palm tree, which I'm going to call X. So in order to find the height, we're going to label our O, our H, and our A, opposite, hypotenuse, adjacent. And again, you're only labeling the two sides given, the 30 and the X. So our reference angle is the 25.7. So directly across from that is always my opposite. Because there's a variable there, we're going to label our O. Next, I'm going to locate the hypotenuse. It's opposite the 90-degree angle. So directly across the 90, there's nothing there. So I'm not going to label hypotenuse. Therefore, the 30 is my adjacent. So what uses O and A? That would be the tangent ratio. So tangent of the reference angle, I'm just using theta, which is a symbol to represent your reference angle. That's equal to opposite over adjacent, right? So this is the equation that we're going to use, and now we're going to plug in from the picture. So tangent, the reference angle is 25.7 degrees, and that's equal to opposite, which is X, over adjacent, which is 30. Since the right side's a fraction, let's make the left side a fraction by putting a 1 under, and then we cross multiply. 1 times X is X, and that's equal to tangent of 25.7 times 30. I'm just going to write this as 30 times tangent of 25.7. We're going to round to the nearest tenth when we type this in. So I'm going to grab my calculator here, and I'm going to type in 30 times 25.7 tangent equals, and I get approximately 14.4 feet for the height of that palm tree. For the next example, we were going to do a project for this unit where you went outside and you measured tall objects using trigonometry, which is indirect measurement. You would make this, which is called a clinometer. And it's really easy to make. All it takes is paper, a straw, and something to weight it down. And it measures your angle of elevation when you're looking up at something. So you would actually look through the straw at the very top of the flag right here, and you would record some measurements. So the measurements you would record would be the angle. So this right here, I know it's kind of hard to read, would be 25 degrees. And you would just have someone read the 25 degrees here. And then you would measure how far away you're standing from the flag. Doesn't matter how far away you stand. So they measured 195 inches, and then there's one more thing that you need to measure from the ground to your eyes. And right here it says that was 60 inches. So this is actually enough information in order to find the entire height of the flag. So if you look at this picture, there is a right triangle that you could pull out. So I'm going to trace the right triangle here. And even though X does not represent the entire height of the flag, I know that from here to here is 60 inches. So once I find X using trigonometry, I could just add 60 inches to that. So let's pull out the right triangle. So I have my 25-degree reference angle. I'm trying to find a portion of that flag, and then again I'll add 60 inches to that. And then I do know the horizontal piece. This is 195, so if I just transfer that up here, it's exactly the same, 195. So just like the previous, let's label our O, our H, our A. So what is the opposite side from the reference angle, the 25 degrees? That would be my unknown, X. Hypotenuse is always across the 90, and because there's nothing there, I'm not going to label my H, and therefore the 195 is my A. So just like the previous, what uses an O and an A? That would be tangent. So tangent of the reference angle is opposite over adjacent. That is the equation we're going to use. So let's fill in from the picture. Tangent, the reference angle is 25 degrees, and that's equal to the opposite, which is x, the adjacent, which is 195. So I'm going to make the left side a fraction by putting a 1 under and then cross multiply. 1 times x is x, and that's equal to tangent of 25 times 195. Doesn't matter the order you write it, so I'm just going to write it as 195 times tangent 25. So to type this into a calculator, and then we're going to round to the nearest tenth, type in 195 times 25 tangent equals, and I get approximately 90.9. So far in this picture from here to here is 90.9 inches. And again, in order to find the entire height, I would have to add 60 to that. So the 90.9 plus 60 more would be the entire height of the flag, which is 150.9 inches. And we're going to represent our answer in feet, it says. So how many inches in a foot? 12. So if I take this and I divide by 12, that would give me how many feet it is. And if you round to the nearest tenth, you get approximately 12.6 feet for the height of this flag. For this very last scenario, we're going to try to draw our own diagram. So we have two buildings in this scenario, and we're trying to find the distance apart. So building A is 480 feet tall, and building B is taller, it's 654 feet. So they know the height of each building. The angle of depression from the top of building B to the top of building A is 42 degrees, so they measured an angle of depression, and they're trying to figure out how far apart the buildings are using indirect measurement. So I'm going to draw the ground here. Here's building A, that would be 480 feet, and then building B is taller. Here's building B at 654 feet. All right, so then it says the angle of depression from the top of building B. So here's the top of building B. So if it's an angle of depression, first we need a horizontal dashed line. And then the angle of depression is always below that horizontal line. And it's from the top of building B to the top of building A. So from here to here, we're going to connect. So this angle right here is 42 degrees. So we need to know how far apart the buildings are. So I'm going to connect from here to here because that's how far apart the buildings are. That's what we're trying to find, and I'm going to call that X. Notice that this creates a right triangle. And I also know in this right triangle a couple other things. I'm going to highlight the right triangle that I'm talking about here. This right triangle right here. There's a couple things that I know. So I'm going to redraw that outside of the picture. First of all, I know that I'm trying to find the horizontal side because that's how far apart the buildings are. Second, I do know one of the angles in this picture. I know that this angle is exactly the same as the angle of depression because the angle of elevation and the angle of depression are identical. And these are alternate interior angles. So my reference angle is 42 degrees. And then the last thing I know is I could actually find the length from here to here. And how could I do that? Well, if I measure all the way to the top of building B, it's 654 feet. And building A from here to here is 480. So I need to take away building A's height in order to get this remaining piece right here. So if I subtract those, you would get 174 feet. So I'm going to label my side length here 174. So once I have a reference angle and a side length of a right triangle, I could use one of my trig ratios in order to find the missing variable here. So my reference angle is 42, so let's label our O, our H, our A. Directly across my reference angle is always my opposite side, and there's something there. There's the 174 there. My hypotenuse is opposite the 90. It's blank, so I'm not labeling the hypotenuse, and therefore My unknown is my adjacent. So what uses O and A? That would be tangent again. So again, tangent of the reference angle is defined as opposite over adjacent. So let's plug in from the picture. So tangent, the reference angle is 42 degrees, and that's equal to the opposite, 174, over adjacent, which is x. So make the left side a fraction, put 1 under it, and cross multiply. 1 times 174 is 174, and that's equal to tangent of 42 times x is just tangent of 42 times x. So I'm just going to write the x first and then times tangent 42. Lastly, the opposite of multiplying by tangent of 42 is dividing both sides by tangent of 42. So this is what x is equal to. We need to plug this into a calculator and round to the nearest tenth. So I would type in 174 divided by 42 tangent equals, and I get approximately 193.2 feet apart.